Hello and welcome. Today we're going to be continuing our basic interpreter that we were working on. Ooh, it's been like a month now. Yeah, we're going to be continuing on this. I haven't had really any free time in the last month, but I do now. So let's continue where we left off. But I think I'm going to need a refresher on where we left off. So if we make and we run this, to do, go to. Fantastic. Let's go look at our parser. Parse, not RS. What? C. Yeah. Where's our, where was that? This was in here on line 57. To do, go to. So this is us parsing a go to statement. Yeah. Okay. If we go to the header, parse H, what do we have in here? Expression let if print and go to. So basically we need to get this go to. Okay. And I guess we're just going down this list and parsing these. So clear. Hold on, let me pull up that basic guide that we were using last time. I should probably throw that in a readme or something. Okay, so we've got this. Ooh, that's not a pretty color. Dark reader. I recently changed my Chrome, or not Chrome, what the fuck? No, Firefox. Yes, Firefox configuration, so that now I'm running in a separate Firefox profile, for stream stuff, and that means that I have to get everything set back up, which is fun. Okay, customize toolbar. So we might be doing this a little bit during this stream, but that is okay. Great. So clear is just a single statement. Do we have like support for this? Not really. I think we can just say AK go to, not go to. What is this? Clear. It's a little bit weird because clear feels more like a function, but it's really not. It's like a built-in. We don't really have functions, I guess. We've got go to, and there's a concept of a function, I think. Yeah, we've got like this def. I don't really know how calling functions work, but I assume that there's like parentheses or some sort of separate syntax. So we'll just we'll consider this its own token, or its own AST item. And what do we do in here? So we've hit this token. Do we need to take it at all? No, I think we've already consumed it. And then we just need to create the expression and set it to be out. So out kind is AK clear. Do we have any other like unit tokens like this? We've got print go to. We've got end. Have we parsed end yet? Let ident clear if end. Yeah, so we just set the kind. Okay, so that's easy. We're gonna skip dim and def. So for go to, we need to read a single integer, which is gonna be like if we open the what are we running in here? foo.base. We get go to, and then we get an integer, and this integer is what line to go to. Okay, so let's see. How are we, if we go back to parse C, how are we getting the next line? So we've got if, we've got an ident. What else do we have? Okay, I don't know. Or I don't think we have anything else. So let's basically just read the next token. So this is going to be DA pop. And this is going to take tokens. And then what does this macro give us? This gives us the item as a token. So we can say token number, or I guess line, is this. Oh, and this needs to have brackets because C is weird. Okay, so now we have the line. then we need to say if line dot kind is not tk number literal, then we're going to have to do some sort of error. Do we have a good error handling method? Parse statement is not 0, then we return 1, but parse statement, I assume here, prints an error. Yeah, okay, literally just f prints. Great. So we can say f print f to standard error, expected line found. I don't know that we have good printing for this. We have print token. Yeah, we can just print the token, that's fine. Found this. Actually we can't because print token doesn't take a file. It's fine, because I think we'll redo this error handling later. So we're gonna just say expected line number. Like we don't even print where this token is. We just kind of say that there was an error. So we'll definitely end up fixing this in the future. But right now we can just return, and then here we can say line dot value number, and then this is going to be, what is this? This is a double. So how do we check if a double is like rounded? Can we do let's see, can we do like let's see, C check if double is rounded, is whole number. That is really tiny. Okay, literally just floor it and check it. According to this one random Stack Overflow. Great. Let's see. Using fmod. Yeah, that works too. Floor. Yeah, okay, it doesn't really matter. We can just floor, and if this is equal to line value number, or we don't even want that. We want minus if fabs. Is it abs f? Either way, we need to import math. Like that, which means we'll need to link with math, but that's fine. We'll do that in a minute. Abs. So abs takes that. Isn't there abs f? Man abs. We've got all of these. F abs. I was right. And F abs. Fabs. Oh, it's okay. So we get this. If it's less than 1e minus 6, then we're gonna consider this to be an integer, and we can just round it. I say round instead of floor because, or instead of just casting it directly because of obvious rounding errors. So we're gonna say round. Yeah, we should definitely round this. Then we're gonna round this line value number, and we're gonna say out kind, and really we should do this here. If it's greater than this, then we're gonna say fprintf to standard error, invalid line number, expected integer, got I don't know, decimal, and then we'll return 1. Expected integer. We can just do that. That's fine. And then we can say out kind dot, not kind, out value, go to, oh shit, we can't call it go to, can we? If we go back to parse h, this guy, We're gonna need to put our goto here, but we can't call it goto because that's a keyword in C. So we'll say goto. Yeah, it's fine. Goto dot line is cast this to a size T. And I guess we don't need to cast it to the intermediate end, I bet. And it's supposed to be a size T, is that correct? Yes, it is. Great. So we get this, and then we can say out kind is AK? Yeah, goto, like that. Great. So now we're parsing this. If we run it, what do we get? Value computed is not used. Where? Parse line, oh, well, that's the expanded. Parse line 83. That's this guy. We don't want it to be used, though. We're just popping a token. Okay, and now we need to, in our make file, we need to link with math. Like that. Okay, cool. Now we get size 6. If we go back and look at our program, we should have 1, 2, 3, 4, 5, 6. That's weird. Because this shouldn't be 6. This should be more than 6. Let's see. If we go back to, actually, do we have a colon in here? I really don't remember most of this code that we wrote, so I wouldn't be surprised if there's like some issues in here. Yeah, like parsing a statement, we don't ever check for a colon. Let's see. Okay. So we have in the main, we have this loop over the things, over the lexer. And then every time we lex, we parse a statement, and then we append that statement. So here we can say for size T, I is less than, or I is 0, I is less than AST's dot count. Then we're gonna say AST is AST dot items at I. Great. And then here we need to figure out a way to print the AST. So we can say parse print AST. And I guess we can take that by reference, because why not? Actually, I don't think there's a need, so let's not. Great. And then down here, let's create a parse print AST. And here you're going to just take the AST. Like that, and then we can go back to main, and then go to parse C, like this. And then in here, what are we going to do? So we're going to need to switch on AST kind. We can do that, and that. And then if we get let, we're going to say printf let. And then what's in AST value let? We get both expression and we get ident. So expression is it's an expression. Fantastic. Which is a dynamic array of tokens. And what was the other thing we had in here? We have the ident. So we can say let ident is, and then this is going to be AST value ident, or value let ident. And then in here, we're going to say for size T I is 0, I is less than AST value. We can say expression exper is AST value let expression. Exper count. And then in here we can say printf And then these should be tokens, right? Expr items is tokens. Okay, so we can say token T is this guy. And then in here, we can actually just say print, what is it? It is Lex print token, T. And then if I is greater than 0, then we're going to printf a comma. Then we can say printf closing curly bracket. Great. So that is just going to basically print this array of tokens. And then, so for if, it's going to be kind of similar, because I think if also just has expressions. Here we can say if, and then what do we have under if? We've got condition, which is an expression, and statement, which is an array of ASTs. Or wait, it's just a pointer to an AST. Yeah, I guess, okay, that makes sense. So if, and then it's AST, so we can say this, and it is a tree, so we can say, so we're gonna have to do recursion here. We're gonna parse print AST, and we're gonna say, what are we gonna say? AST value if statement. And it's a pointer, so we can dereference that. Then we'll close this parenthesis. And so that gives us our statement. And then for the expression, we're just gonna do the same thing that we did before. And we can even say then if we want. Great. For print, it's gonna be similar to this guy. Except instead of any sort of variable in here, we're just going to do this. And then for goto, it's going to be similar again. Except for here, it's just going to be goto %lu, I think is what it is. AST value goto dot line. Like so. End and clear are both fairly simple, and it's just going to print end, and clear is just going to print clear. Great. And then it doesn't return a value. Oh, this is supposed to be void. Okay, if we go back to main, then we're going to loop over this and we're going to print this, and then we should print a new line. Okay, a equals numlet 0. So that is good. This is not. Okay. What is the issue here? So we get this array, we get equals. Oh, that equal sign shouldn't be there, but that's fine. We can fix that in a moment. For now, we need to figure out what this seg fault comes from. Oh. This needs to be if. I don't know if it matters, but it's important that that is that. Not statement. It's going to be, wait. The condition is an expression. The statement is the AST. So it should really be like this. Yeah. Okay. Print here also needs to use the correct thing. So this should be AST value print expression. Cool. So now we get A equals 0. So we notice that the :B part just gets chopped off. Here we get if ident A is greater than 100, then we end. Then we get print ident A. Then we get T equals A plus B. A equals B. Okay. So, one thing I noticed is that when we parse let, right about here. So, okay, so the way that we're doing this is we're taking, so since you can, for a let expression, since you can either use let A equals 0 or just A equals 0, we're going to say if we get let, then we just take another token and we kind of ignore the let token. And then we come through here, and then we start parsing an expression. So really what we need to do is we need to say, like DA pop tokens, and this is going to be token eq is this. If eq dot kind is not tk equal, then we need to fprintf standard error unexpected token lex print, basically copying this like that, and then we can fail if we don't have the token that we're expecting there. And that way we don't get the equal sign in here anymore because we've popped that token and we can ignore it. Cool. So that's good. We need to also fix the B part of that. So in basic, any expression, what was that? Oh, there was, yeah, BW basic, great. Any expression, so you see we have Fibonacci here. Any expression here can be separated by colons. So I think you could even do, or since we go 220, that doesn't really work, but we could do something like this. And I think it's still valid. Yeah. So like it should be, what is it? That, and that gives us that functionality. So we need to figure out how we want to parse that, because right now parse statement just returns a single AST, when in reality it should probably just return a bunch of statements. Like this should probably return ASTs. Yeah, I think that's fine. It's a little bit annoying, but I think that's fine. So we do have a concept of an AST. Wait, so parse statement, is this the one that's called on each line? We don't ever do parse expr. That's interesting. We'll figure that out. So parse statement is going to use ASTs, and then we actually have that defined in here. But we're going to move that into here right after we define AST. And this is just a dynamic array. So that's cool. This is going to be ASTs. Oh, fuck. What is this going to be then? This is going to be an array of arrays of AST, which is ASTs. So that's awful, but we're going to do it. So this is going to be, I guess this is like lines ultimately. Yeah, I think lines is probably the best name here. So J, and then this is going to be line items at J, and then here we're going to say line as well. And then I want to just printf open, and then print if J is greater than 1 or greater than 0, printf comma, and then we can finish that with just that. And so that shouldn't change a whole lot. It's probably not going to compile because we're still expecting in parse C. So let's first of all mem set out size of out 0. That's backwards, I think. I really wish I had Shift K set to open the man page still, but I messed that up and I need to fix it. Okay, let's see. So area pointed to by S with constant of byte C, and C is the second argument. So it should be 0 and size of out. Like that. And then we can import string .h. Okay, and so that will give us just a 0 initialized array, which actually in reality we don't want that. We want you can go away. We actually just want to say out.items is 0, or out.count, sorry, is 0, and that way we basically empty the array, but we don't have to like reallocate the memory or anything. If we just mem set it, then we have a potential memory leak there, because we are effectively losing reference to that array without freeing it, which means that it's just allocated and floating. Okay, so we're going to say DA append into out. We're going to say we're going to put a token, not a token, we're going to put an AST with the kind and value being these. Not like that, but like... No, something here is wrong, and this is awful. Oh, this should be commas. Dude, this formatting, what the hell? Okay, that can be like that. That can be like that. Wow, this is really badly formatted. What the fuck are you doing, Vim? Boop, boop, boop. What is this? Oh, that's for the let. Like that. And this is really annoying. What is this? C parent error? I thought I fixed that. C error in parent. But I also want... Isn't that how that works? I don't know how to Lua. Syntax clear C, what is this? C parent error. Nope, not quite. Great. Error. This is default NeoVim. This is beautiful. Can I not do this? I thought I can do something like this, I think. No such highlight group name. Yep, that would make sense if you're parsing it like that. There is a way to do multiple commands in one, but I don't actually know how to do this. So we're going to do something a little bit silly and just do that, because I don't want to mess with it right now. But yeah, okay, so now our error isn't all messed up anymore, which is good, because that's, or I say our error, the syntax highlighter basically just breaks right there. Okay, great. So I've got this. Now we just basically need to redo this for each of these. I did not mean to do that. Okay, so we're gonna grab this, put this here. Kind here is aka clear, and we don't care about the value at all. So value go to, line is this. And this type is go-to. Field designator line does not refer to any field in let. Correct. Do I need to still specify this? No, I don't. Okay, so we can clear that here too. Great, and then we can grab this guy, chuck it there, ak if, and then if. Then we can grab these and put them there. And then grab these and kick them there. Why are you 2 space indented? Wait. Incompatible pointer types passing AST star to parameter of AST's star. So statement... Oh shit. So this is a little bit weird. We do need to make the distinction. Okay, no, you know what? Let's undo all of this. A little bit annoying, but that's fine. Let's undo all of this. I want to keep this function just taking an AST. Like that. Like, what am I doing? Did I just create a, no? Okay. And then in parser H, I want to make this still take an AST, but I want to have like a parse line, and since we're not using expr, I'm just going to use that. And then this is going to take the line and return ASTs. And this is just going to take tokens. And then in here, this is going to be, we can copy the signature, this, and then what are we going to do? So in here, we take this, and then we're going to say parse statement with line and AST as a pointer, and we're going to say AST is 0. I'm going to say out, or we're going to say DA append AST out. Like this. Sorry, like this. And then int ret, if ret is not 0, we're going to return ret. That's fine. That's just if we hit an error, let's return it. And then what? So this should continue working like normal. If we go back to main, we actually want to, instead of saying parse statement, let's say parse line. Not that. If we make and run, we should get the same thing that we did before. So we get let a is that, we get this if, then we get print, then we get let t, let a is b. Okay, yeah. So all of that is the same. And then what we really want to do, we want to say if line count is greater than 0, and what? And I guess no, if line count is greater than 0, then we're going to say a DA pop line token next. I'm going to say if next dot kind is TK colon, then we're going to say, or if it's not a colon, then we're going to print an error. unexpected token I also just realized this is okay, let's modify this a little bit to take a file. I guess stream is the convention. Stream, then Elixir C, print is going to take the file stream, and then replace all of these, everything here that is printf with printf parentheses with fprintf stream that. So now we actually output into a into whatever stream we want, which means that when we call this in the parse here, we need to say standard error. Like this, and then the line here can be like that. And then here we can say print, let's grab this guy. Actually, let's grab both of these guys. Put them there. And this token here is next. And so this checks if we have a colon. And then after that, we could just do like that if we really wanted to. I'd rather not, though. That's a little bit weird. Also, fucking C. What the hell? That's fine. We're basically gonna just do a while loop. We can just say while true, really. So, if line count is 0, then we're gonna return, or break is fine. We can return 0. And then otherwise, we're gonna do this. And this is the check of a colon. If we don't have a colon, then we're gonna error. Okay. This, why is it just printing this? It's kind of close, it feels like. We get let A, we get let B. The expression here is wrong. Actually, all of these expressions are wrong. Oh, I know what the issue is. This is standard error. This is standard out. That's great. That's because this needs to be printing to standard out. This needs to be printing to a stream. We'll make this also take the stream. Just in case we need it in the future. Then we go to definition of this. It'd be really cool if we could go to definition on that, but we can't. That's fine. Standard out. And then in parse.h, this needs to take the stream. And this probably also wants to include standard IO. Like so. Okay, what now? Incompatible type for argument 1 of that in parse.c 164. That's because we need to type stream. Like that. Okay, so A equals 0, B equals 1. If A is greater than 100, then end. Print A plus B, B equals T. Okay, so we have this parsed. Okay, that's cool. I think we're good on that front. That's kind of perfect. Now, let's create source. What do we want to call this? Either so this is the actual interpreter. I'm thinking God, names are hard. I don't want to just call it interpreter. That's a really long name. Eval? Yeah, let's call it eval. That's an easy name. We need eval.h. So in here, let's create our include guard. If def eval h, define eval h, and diff eval h. Great. So then in here, we're gonna have a pub. What the fuck? This is not Rust. So we need to have a concept of a value. So this is gonna be pub. God damn it again. This is going to be type def struct value, I guess. Where we're gonna have a this is not how you do this. I'm really clearly not being very good at C today. Type def struct value. In here we're gonna contain, I guess for now we're gonna have numbers and strings. I don't know if there are other values in basic right now, or basic, but right now we'll just do this. So we're gonna have value. We need a kind, so we can say value kind, and we'll have value. Yeah, I guess that's fine. And really this can be an enum, or not an enum, what is it called? A union. Where we have we don't have strings, but we can have it just a char stars. Do we even have strings in basic? I assume that there's some sort of string. Although I don't really know. We don't have like lexing for strings. I think we literally just have numbers. So I guess for now, let's just have numbers. I want to keep this like value structure, just because that is going to be useful if we do add other types, and I don't think we need to, just assuming that we only have numbers is kind of dangerous, I think. So we're using double, I think, for our precision. If we go back to our lexer, we use double for our numbers. Yeah. So double, number. And then for value kind, I would like that to be its own thing. So type def enum value kind. We can have a vk number equals 0. I think you have to do in C, or you should do in C. Okay, so now we have this, and then in here we're actually going to this file is going to do the evaluation. So we're going to say int, not int, I guess is fine. And we're going to say just eval line. No, eval AST. Takes an AST. Include parse.h. So it's going to take the AST. And then we also need to have the, like, the VM, I guess? No. You know what? Eval doesn't evaluate an AST. It evaluates, just in general. And then it takes the VM. And we're going to call it a VM. I don't really know that VM is the correct term, but it's going to hold all of the state. So we're going to have the ASTs, which is going to be lines. And really, they're not even ASTs. They are, if we go back to main, how do we store this? So we store token lines, which contains the line. Interesting. So yeah, we're gonna need to excuse me. Right now we don't actually associate ASTs with their line numbers, but we definitely need to do that. So in our lines structure here, I'm actually going to move this into eval. No, actually, I'm going to put this in parse. Parse seems like a better place for this. We're going to have this. And then instead of this holding onto ASTs, it's going to hold on to a typedef struct line, which has an ASTs, and a line number. Like so. And then in main, instead of appending AST, we're going to say line with ASTs is this, and line is line dot line. This naming seems to be working very brilliantly. Okay, like that. And then in here, instead of this being that, it's going to be dot ASTs. We can even printf ASTs dot not that is dot items I dot line, like that. Cool, and we run this and we get the line numbers now, which means that we have that associated. And then in here, this can hold on to a lines. Cool. And so lines here is our dynamic array of lines. Great, very descriptive. Okay, and then we also, what other state do we need to have in here? Honestly, not quite sure. Let's go look at our foo example again. So we have, we need to create like a map of variables. And so for the time being, we'll just use like an associated array variables. We could bring in something like GitHub nothing's stb. I think is what the, yeah, so there's a like a hash map in here, I think. I think he has a map in here. STB is a great collection of header-only libraries, by the way, that if you're looking for some cool tools, definitely check it out. I'm certain there's a map in here, or a hash table, or whatever you want to call it. Okay, maybe there's not. That's gonna drive me nuts because I'm certain there's something in here. But I guess not. That's fine. Yeah, whatever. Either way, like an associated array is just fine for now. Typedef struct variable. It is a little bit annoying that we don't have like pairs in C. There's a lot of like really nice type stuff that we could have in C, but we don't because it's a kind of old and kind of awful language. Const char star, it's gonna be the name. And here we're gonna have the value, which is like just literally just a value. And we're not going to garbage collect or anything. I mean, at this point, we don't have anything to garbage collect, but we would eventually want a garbage collector somehow to, or like a reference counting or something, but it doesn't really matter yet. And actually variable is a long name, so let's say var and vars. Items, size, t, count, capacity. Just the standard dynamic array. So we get lines, we get variables. What else do we need? Let's go back here. I think that might be it. Also, something I'm curious about. If I come here and I say go up to 15, does this still work? It doesn't. Oh, that's interesting. I was kind of going under the impression that it would work, but I guess that makes this even a little bit easier. Okay, so now we have eval. I guess like in reality, all of this could also be like internal. We can make this like a opaque structure or something, but I don't think it really matters. So now that we have eval, let's go to in here. Include eval h like this. And this should really take a start of the VM. It doesn't really matter, but it kind of shows to me that it modifies it. Or I guess it does matter because of, yeah. Okay. Oh, we also need the instruction pointer, obviously. Which I guess is a little bit weird. And I guess, we can also just do stopped, which is, do we have bool? Do I need to include standard bool? Let's do it anyways. This is a little bit weird, because instruction pointer is not quite right. I guess current line is a little more accurate. It's just going to be the line that we're on, and we're going to loop until we're stopped. So we're going to say, we're going to say while not VM stopped int or eval line VM, and then I guess we'll say VM current line. No, we don't even need to do that. It can get that. And then int eval line takes the VM. And then here if ret, return ret. And we're just going to assume that errors are handled as soon as they exist. Okay, so here we're going to say we're going to say line from parse h. Line is VM lines items VM current line. And we should probably bounce check this. So let's say if we can just assert. No, assert from you. VM lines. Or I guess VM current line is less than VM lines count. And then for size ti, 0i is less than line count. Or I guess line AST's count. We're going to say eval AST. And it's just going to take the AST, which is going to be line AST's count or items at I. And then we're going to say int eval AST VM and the AST. And we definitely need to take the VM here. Great. And then here we're going to match on the AST. No, we're going to switch on the AST kind. if we get a let, this one's fairly straightforward. We need to say VM. You know what? Also in here, I want to define a couple of functions for operating on our variables, on our variable map. So we're gonna say bool parse get var. And parse is a little bit weird here because it's not parsing or anything. I'm doing that because we're in the parse module, I guess, or not module, but file, and this will prevent us from getting like conflicts. So this is gonna take the vars. Oh, sorry, not parse, in eval. Yeah, so in here we're gonna say vars const char star name, and then this is gonna be value, and then we're gonna say set var, which is gonna be very similar, except instead of that we're gonna take value by value, and we're gonna take vars by reference, or by pointer. Yeah, that's fine. Cool. And then we could also do like get lines. I don't know that that's really necessary though. So now in eval C, let's implement these functions. And the advantage of putting this into the header as well is that now we can, if we want to, we can set it from the main program. So you can have like predefined variables and stuff. So get var is basically just gonna be for size t I equals 0, I is less than vars, count, if stir in or stir comp name and vars items I name is 0, and we're gonna return vars items I name. No, we're gonna say out is this. We can include string. Then we're gonna just set that. And no, really what we can even do, we can take this by reference. And just give a reference to that value. Yeah, I think that'll be cool. And we're gonna return true and return false if we don't find it. Okay, and then similar concept here. Where we're gonna walk. If we get a variable with the same name, then we're going to say set the value to out. And I guess set var doesn't even need to return anything. Yeah, set the value to out and then return. And then if we don't ever do that, then we're gonna say da append vars var with name is name and value is value. And this comes from macros. Like so. Why are you mad? Can you guys stop? See error in parent. I thought I have that fixed. I do. Why are you so mad? That's really annoying. It's fine. Okay. Yeah, okay. So now we can say eval set var VM vars by reference, and we're going to say name is going to be ast value let ident ast value let expression, and this is something we're going to need to parse, or we're going to need to evaluate this expression. Okay, that's fine. Oop. Int eval expr takes the VM, takes the expression, and it's going to return the value via pointer. So we're going to evaluate this, pass the VM. The expression is this guy. And then the value is value. I guess, wait, we can literally just say if this return 1. Nah, we can do that. That's fine. And then if this return 1. This can take the value as well. Statement requires expression of scalar type. Void is invalid. Right, because set var can't fail. Okay, so now for evaluating this expression. This is probably the most complicated part of this, to be honest. And it's not even all that complicated. So all of our expressions are very simple. We're not even doing functions or anything. So we're just going to use a fairly simple, and functions do exist, but we're not going to implement them yet. So we're going to do a very simple, what is it called? Reverse Polish notation, or what is it? Postfix implementation. So infix to postfix. I don't want a calculator. Algo, because I don't remember how to do this off the top of my head. Okay, if the operand is encountered, add it directly to the output. If an operand is... Okay, this is fucking stupid. Give me like a super simple code. Fuck, I don't want to read C++. What the fuck? Okay. Tokenize the infix expression. I mean, all of these work. They're just all... I wonder if Wikipedia has something. Because Wikipedia's algorithms tend to be fairly simple to read. What the... Why are you moving content so much? The current token is an opening bracket. Push it to the stack. There's a closing bracket. Fuck off. Give me something super simple. Sure. While there are more symbols to be read the next symbol. If we get an operand, output it. What does it mean to output? Oh, okay. Put it into the onto the stack. Okay, this is probably fine. We're gonna use this whatever super simple thing from some university. I can do, what is it? It's like navigator dot filter. No, dot style. Hold on. I have a little bit of JavaScript that I have somewhere that will give us like dark mode on this. Yeah. Viewer. I don't know where navigator came to my mind. Style filter invert 1. Beautiful. Okay. While there are more symbols to be read, read the next symbol. So basically, for, and then here, I guess we can have, we can literally just create a new expression. Postfix is for size t, I is 0, I is less than x per count. So go over all of these expressions, and then let's match based on the current. So we can say AST. Wait, no, an expression is a bunch of tokens. So we can say token is expr items I, and we can switch on t kind. And there's a bunch of tokens in here that we just can't get. So parentheses we can get, commas we cannot get, identifiers we can get, colons we cannot get, numbers we can, these guys we can. This is interesting. I didn't even think about this. Do we want to have a Boolean type or just use integers? I think for now let's just use integers. We can do a Boolean if we need to later. None of these are valid at all. Okay. This unreachable is really just the truth. And then I guess here we can just return 1. Or really return 0. This isn't actually ever reachable. Or it is right now. So we'll keep that, I guess. Okay, so if we get let's see, if we get an operand, which is a identifier or a number literal, then we're gonna say double D. Yeah, actually, we can just say double. No, we're gonna have to special case each of these. That's fine. So identifier, we're gonna need to say expr, or no, we're gonna say eval get var from VM vars by the name of t dot value into out. We can 0 initialize it because why not? T value here is ident. Undeclared label var. What do you mean? Can you not do, you probably can't do a pointer to a pointer. You know what? Okay, get var really doesn't need to be this sophisticated. It doesn't matter. Okay, so now we get the variable. And then, or I guess we could have just used null here. It doesn't matter. If it doesn't exist, then we're gonna printf into standard error, undefined variable t value ident, return 1. So we've got, we checked the variable and it doesn't exist. That's fine. And then eval expr. So we're gonna just say push or actually also just realizing this. This is converting. I mean, I guess what I did look up was converting into this, but we don't actually need to convert it. Whenever we push a plus, we can just evaluate that. Eval infix operation. In fact, infix expression. How does this one work? Meh. Yeah, you know what? This is fine. Basically, just whenever we let's build this, and then we can clean that up because that'll just be easier, I think. So we get this variable, which means we have the value, and then what are we gonna do with it? So we've got this value. We're just gonna say postfix. Ah, fuck. This isn't even an expression. This is value. What is this? Yeah, you know what? Expressions is slightly wrong, or expression is slightly wrong, because like we're not gonna have any of these tokens, but it's fine. We're just gonna say postfix da append postfix token. Kind is tk numlet. Value number is var number. Too many arguments provided to function like macro. That's true. This needs parentheses. Expression is not assignable. Member reference of type expression. Correct. Okie dokie. Yeah, that's cool. That's done. Basically, if we get a number literal, then we're just gonna push. Yeah, if we get a number literal, we're literally just gonna push the token. Okay, if we get an L parent, then we're gonna push it on the stack. If we get an R parent, then we're going to say while stack, I guess we have DA peak, which I get, no, that's not quite right. We're going to say while DA, not DA, stack items, stack count, -1, kind, is not tk L parent, and we've got items. Stack count minus no, in parse we've got these two macros that can be moved into macros. Because peak does what I'm talking about. Like this is just DA peak. So peak on the stack. If we get kind is L parent, then we do that. Yeah, and then I'm gonna say DA pop stack and DA push into postfix. DA append. Like so. And then if, so we're gonna pop. If popped is the L parent, then we're gonna continue. I guess we can really just break. Which means we don't even need this. Cool. So now we have this, yeah, we're pushing all the things into there. We're gonna hold off on greater than and all of this. Let's do plus. Ooh. So this is an operator. Pop higher or equal precedence operators from the stack to the output. Okay, so we're gonna say int prec, or yeah, prec is actually we don't even need to. We can literally do all of this. Yeah, so it's op prec of t kind. Switch over this TK. So if we get greater than, all of these have the same precedence. We can just say 1. Actually, we'll say this is 1, this is 2. So the current precedence is this. And then we can say while stack count is greater than 0. Then we can say token peak is DA peak of stack. If peak.kind. Wait, does this? What is this? Okay. Peak.kind. Yeah, so if op prec of this is greater than or equal to prec, then we're going to say DA pop from stack, and we're going to DA push or append into postfix. And this is where we do the evaluation. Okay. So if we get that, then we append. So if we get a higher or equal precedence operator, then we're going to push them into the output. Stop before popping a lower precedence operator or a L parent. Like that. Then we're going to do this. Otherwise we break. That seems a little bit weird, but that's fine. And then here we can just return 0. Okay, I think that's pretty much it. Before we actually get to that point, I want to. So we're not actually evaluating right now, to be fair. I want to go to parse and grab this expression printer. Like that, just so we can print what the postfix is. And if we run this, what do we get? Nothing, because we don't ever call that function. That is completely correct. So now we can say eval, so we need to create a VM. Which means we need to actually include our evaluator. And we need to have, so current line is 0. That's not actually strictly true. We're gonna have to figure that out, but I think 10 is actually the start. Let's go back to our foo. Yeah, 10 is our start. Lines is, what do we call it? We call it ASTs. Stopped is false. Vars is 0. We can say eval VM. Okay, we got an assertion failure. Which is current line is less than. Right, so current line is actually a little misleading right now. I'm gonna just remove this assertion. Fuck, I can't. So we need to actually get the correct line. It's not just an index here, which is a little bit annoying, but that's fine. So this is actually, instead of doing this, this is gonna take a line. And then in here, we're actually gonna find the line. So we're gonna say for size ti is 0, I is less than VM lines count. I'm gonna say if VM lines items I equals VM current line. I'm gonna say line is VM lines I. And we can even do this by pointer. And then if line is null, it means we didn't find it. Printf into standard error. Invalid line number. And this is going to be VM current line. Like that, and then we can push line in here. Line can be done by ref or by pointer. It's fine. It's not really necessary, but it's fine. And then we just need to default to return 0 on everything. Like that. And then if we run it, ooh, shit, we just get an infinite loop. That's very cool. Let's see. So eval expert is where we are. Where does this function get called? In here. Where does this function get called? In here. Oh, but we never update the line. Yeah, so we can say size t current. No, it's a little bit weird. We basically need to say that if we don't go to that we want to just increment the line. So if we don't set the line, then we want to say VM line. Basically, we're going to find the current line again. And then current line is going to be VM lines item or lines items I plus 1 dot line. And then if so if VM lines items I, or not even that, if I is VM lines count minus 1, then we just say VM stopped is true. Right, so if we're at the end, then we're just gonna mark it, we're just gonna stop and then move on. So we get 0 and 1 as postfix. This is just wrong. That's fine. We can fix that. Okay. So let's see what's wrong here. So we get precedent. While there's items on the stack, push them. This is wrong. Push the operator on the stack. That's something we didn't do. I actually really don't understand how we ended up with the plus on the postfix stack. It's a T. Yeah, T. where was that? This, into stack T. Which also didn't do anything. So we start off with 0. I don't understand why we go both in postfix and stack. So in this case, we're getting just numlit, which should just push this into postfix. And then we break, which puts us down here. So how is that ending up in stack? I'm so confused. What? Oh, well, I'm being fucking stupid, so this needs to... Oh, I'm being really stupid. Okay, so we end up with postfix is 0, postfix is 1. This is kind of weird. There's a lot of... So 0. This is weird. So we get 0 here. We get 1 here. That's good. Then here, we get 0, 0. Which isn't wrong. And then there's also pop remaining operators from the stack into the output. So when you say while stack count is greater than 0, da append postfix stack dot count. No, da pop stack. How do we get a plus here? Like, how the fuck does that happen? Like, if I do this... Actually, I don't even care about the stack. Oh, well, also, this isn't the wrong spot. This needs to be down here. That would be why. Cool. So we get 0, 0 plus. Great. Okay. So now, when we get here, we're going to have an int. Not even that. It's going to be a... I don't know. This is weird. We need to evaluate... Oh. Excuse me. We need to evaluate a single operand. Which doesn't even need this. It just needs the expression stack and the token kind op. So we still have these guys. And then really, we don't even care. We can just say, or we also have num. No, we don't. We literally just have these. And then I just want to say default. What the fuck? Default is assert 0 and unreachable. Okay, so if we get greater than, we're gonna say DA pop stack. This is a token. If TK kind is not, I think we can just assert here. TK kind is TK numlet. And then we can just say this is, well, this is A. This is B. And really, it's that. And then we can just say DA append stack token kind, what the fuck? Token kind token. Kind is numlet. And value number is A is less than B. And then I guess the C will coerce that into the double that it needs to be. And actually, nope, that's not going to work. I was thinking we could do some sort of fall through magic to make it so that we don't have to repeat this code, but I don't think we can. Greater than or equal to. This is literally just backwards. Greater than or equal. Break. Wow, typing's hard. Less than or equal. And plus. Okay, and then instead of pushing this onto the postfix, we're gonna say eval operator, which takes the postfix stack and the this guy, and just does the magic that it needs to do. Kind. And then we do the same thing right here. So this is going to be really hard to tell because it'll all be zeros, except for this guy, which is not a zero. But I think we should be able to say assert postfix count is 0. And then how do we return? We'd return value like this. So we can say postfix items 0 value number. So we're going to say value kind is value kind number. Value number is this guy. Sorry, not 0. It's going to be 1. Oh, actually, something else you notice now is that the variables are actually set. That's kind of cool. So we're going to implement print, and then I think we're going to wrap it up for today. Just because if you can't tell, I'm getting a little bit exhausted. Okay. Excuse me. Great. So where were we? Here. So eval ast print break. Let's grab the value. If has a, not if, print has an expression that we can do. And then here we can say match. Nope, we can say switch. Value kind. If we get a number. Yeah, if we get a number, we can say print f value kind, or sorry, value number, and it's a double, so it's it's an LF. Okay, so we print 0, 0. Does that make sense? Is that correct? No. Why are we printing stuff twice? Also, line 62 should have a return 0. Also, we can just replace this with default, and that's not an issue anymore. Great. What is the issue? Why are we printing twice? That doesn't really make any sense to me. And 30. What? 20 doesn't even print. Oh, wait. Okay, so we get the 0. That's the same 0 we get there. The printing is a little bit different, but that's fine. But okay, so we get our print. That's cool. So this guy, yeah, we get our print here. I'm gonna remove some of this. No, actually, I'll leave this logging for now. We can clean that up once we actually have a working project. But for now, let's wrap it up. So to do that, let's commit all of this stuff. So this is basically actually, let's git reset, git add source, and make file. And then here we're gonna say finish parsing and start eval. You can go ahead and push that. So now that should be in the repo right here. Can be accessed from here. And that is going to be all for today. So thank you everybody for watching, and I will see you next time.